in a very nice sunny day in Toronto, which is unusual. We are in the receiving and shipping end of CVMR Corporation in Toronto. My name is Cameron Kozan. I'm the chairman and CEO of CVMR Corporation. CVMR has 22 operations around the world in 22 different countries and has been here from day one some 40 years ago. The acronym CVMR stands for Chemical Vapor Metal Refining. There are three general methodologies for refining metals: pyrometallurgy, hydrometallurgy, and a term that we have coined at CVMR called vapor metallurgy. Pyro and hydrometallurgies devastate the earth, leave tailings behind that are harmful to the environment. Vapor metallurgy, on the other hand, is a process that is environmentally neutral. It does not use water, does not use acids, and the tailings that it leaves behind are absolutely neutral to the environment. This is the methodology we use, and not only we have invented many aspects of that and continuously renovate and innovate whatever we have been developing. Over the years, CVMR has been able to produce 150 different patents. Some of them have expired. The ones that have remained in effect are being upgraded, renewed, and added onto. We refine 36 different metals, including all the rare earth elements: nickel, copper, cobalt, iron, molybdenum, tantalum, niobium, and so on. The methodology we use is well known, is 135 years old almost, and is used by 5 different corporations around the world, including our own operations in different countries. We are in 22 different countries, and we operate with a difference. We do not go to third world countries where the minerals exist most of the time and concentrate and ship them out. We try to build refineries in the host countries. As a result, we are welcome in those countries because we create jobs, we train people, we stay where we are doing the mining and refining, and the host countries understand that our interest in their minerals is long-term. We also invite the host countries to become our partners in the ventures that we have, in the operations that we have. As a result, we have a very good relationship with those countries. We have built schools, we have built clinics, we have established various chairs of engineering to teach students the methodology and the process we use at CVMR, so the host country can supply the labor force that we need. And that is another dimension of improving the economic well-being of some of those countries that we operate in. Most of our mineral resources come from Africa, but not exclusively. We have mineral resources in the heart of Europe, in Turkey, in North America, especially in Canada, where our head office is today. CVMR, although is a private commercial entity, has had some interest in scientific endeavors. Primary among them was the Sudbury Neutrino Observatory that won the Nobel Prize in 2015 in physics for Dr. MacDonald. Over and above that, we have had many other accolades to our name, one of them being the printing of the US dollars, making the money plate, I should say, for the US dollars in Canada. If the cameras allow you later on, you might be able to see the first print of those US dollars that was sent to us by the Department of Treasury, and we thank them for that. The process we use is rather unique. Imagine the ore coming out of the ground. You mill it to about 200 mesh. I am simplifying the process. We put that material on a conveyor belt. It goes into a chamber where, depending on the metal that we are after, we pass certain gases over it. The reagent has to match the metal that we are after. The reagents react with that, the atoms of that metal, lift the atoms up, so you have a vapor inside that chamber that is pregnant with those metals, with that single metal, I should say. Then you push that into another chamber, you put some heat and pressure, depending on what it is and how you want it, and it precipitates, it drops those atoms of metal out of the vapor in 52 different forms. Nano powders, coatings, big chunks of metals, and so on. We can even mix some of those vapors and create super alloys, which are very useful to certain industries. Over and above that, we use the same methodology by capturing methane and or CO2 and converting those elements to graphene and graphite. The graphites have had many uses, of course, from medicine to production of electricity, which we are endeavoring in one of our subsidiaries called MPower Corporation. Although the chemistry being used in vapor metallurgy is 135 years old, we innovate continuously. Use of this technology today, if someone wants to use the latest form of this technology with all the advantages that the new technologies, peripheral technologies, have contributed to it, they have to be licensed by CVMR. CVMR does license other organizations to do this, but in most cases, they prefer if we license, we build, and we operate those plants around the world. The latest we are endeavoring to do is two plants that we are building in Europe. Our iron powder manufacturing unit in India is hopefully going to be commissioned, barring any accidents, by the end of this year, 2025. After that, I think we have to start what we have been promising the world and the US government, is our nickel operation in the United States. The final products we develop, from nano powders to powders and so on, also include very complex net shapes for waveguides, for insulations, and the sort of things that highbrow organizations such as NASA and defense industry use. The products that we manufacture have uses in medicine, in food supplements, all the way to defense industry, medical industry, electronics, computers, EV batteries, and injection molding, 3D printing, and so on. The technology that CVMR uses is so precise that it can decontaminate materials that might be contaminated with uranium and derivative products of uranium, radioactive materials. We decontaminate radioactive materials, radioactive elements, such as stainless steel, nickel, iron, and so on. And we can separate the two such that the nasty materials go back to the government and the pure material stays with the commercial entities that we run. This has been tested. It has been performed to the satisfaction of all institutions that regulate such things. And there is a white paper issued by BWXT of the United States that you can find on our website. This is unique. This is something that not many other organizations can do, but our technology at CVMR allows this process. CVMR is a NATO supplier. We have a NATO supply number. We manufacture our products and sell them to major institutions in defense, pharmaceutical, and electronic industries. Among the major institutions that we are involved with are Oak Ridge National Lab, Ames National Lab in the United States, the defense industry in the United States, Department of Treasury of the United States, Department of Energy, and Departments of Defense in Canada and the United States.
This is the TGA. When we receive the sample, we want to do a baseline test to optimize the parameters. So we receive sample, we take 10 grams and charge it into this TGA, and we pass the process gases at certain temperature and pressure, and we can see the real-time kinetics on the computer. So as we progress in the test program, we can change the parameters and optimize the parameters. So this is the first thing when we receive a sample from client for carbonylation, nickel, iron, and other metals. That's what we do. So this is the first stage. Second stage of piloting, this can hold about 10 kilograms of sample. We optimize the parameter on the TGA. We bring this another batch of material here, charge it to the reactor, and then we go through the process using the data optimized on the TGA. So this is the reactor. This is the booster for recycling the process gases, and this is the liquid storage tank. So when the carbonyl form here, we will collect the liquid carbonyl here, then we take the liquid carbonyl and decompose into different powder. It can have different morphology, different size, different structure. That is the main purpose of it. It will produce 99.99 purity nickel or carbonyl powder, iron powder. This is the third stage piloting. It can be done for feasibility studies. This can take in about 1 ton of feed material. Then we pass the carbon monoxide gases through the reactor. It forms nickel carbonyl or iron carbonyl. We take the carbonyl in the vapor state to the powder decomposer. In the powder decomposer, we produce nickel and iron powder, and it will be collected in the powder collector, or we call it consolidator. So the gas will come back, go to the compressor and compress it, and back to the reactor. So this is a closed loop. There is no leakage. There is no gas leave the system. It's a closed loop system, 100% recycled CO. So that's why it doesn't pollute anything. We don't have any liquid waste or any residue. We only produce the powder, and the residue can go back to rehabilitation. So there's no chemical added to the feed material. So when we receive the sample, we have to know what is the metal content in the sample, so we can target the extraction rate. So we do XRF analysis. This is the latest version of the XRF analyzer in the market. So this analyzer can read it to very accurate level of nickel, iron, cobalt, transition metal contents, to some extent rare earth metal as well. So these are the sample we receive from clients from all over the world. This is something from Enami in Chile, and this is sea nodules from Poland, and we have other metals. We have lithium from Bolivia. So we have several metals. We try to do XRF analysis when we receive the sample, so we can report to the client, this is the metal content of the sample they sent us. This is the feed material for iron carbonylation plant that CVMR is currently building it. This is called sponge iron. It has 75% to 80% iron content in it. This is a readily available feed material, so you don't have to produce the feed material for the carbonylation plant. This, because of the availability, we chose this material. So because of this material, the plant is very sophisticated. It is almost at the end stage to commissioning.
In this booth, we are depositing nickel mold on the masters. So we have different chambers of nickel carbonyl, and for nickel carbonyl, this is the medium chamber. This is the master. What we will do, first we have to clean everything, then close the chamber. Now our liquid nickel carbonyl coming from the other side. This is the processing section to filter and flow control of the liquid nickel carbonyl. This is the vaporizer, where liquid nickel carbonyl vaporize in the gas form. Then it comes to the chamber. Chamber we keep certain temperature, so when vapor nickel carbonyl enters in the chamber, it decomposes on the surface of the mold, surface of the master. So we have to run usually 24 hours or 36 hours depending on the thickness. And at the end of the run, we have to purge the chamber and open and release the mold. So this is the masters, and I have a sample of nickel mold also. I can show you. These are the pure nickel mold. Is for some type of electronic parts. It's etched on the silicon wafer. So we have to put this one inside the chamber and heat it at certain temperature. Then from the top we have to introduce the nickel carbonyl in vapor form. So nickel carbonyl will decompose on the surface.